5 differences between CMOS, BIOS, and their functions. CMOS, Complementary Metal-Oxide-Semiconductor, and BIOS, Basic Input-Output System, are 2 distinct components in a computer system. Here are 5 key differences between them along with their functions. Number 1 is let's delve deeper into the nature and location of CMOS and BIOS. Nature and location. CMOS, Complementary Metal-Oxide-Semiconductor. Nature. CMOS is a type of semiconductor technology used to create integrated circuits. In computing, CMOS also refers to a small amount of volatile memory. Location. The CMOS memory chip is usually located on the motherboard of a computer. It's a small integrated circuit chip that may be housed in a dedicated CMOS battery-backed RAM, random access memory, module. BIOS, Basic Input-Output System. Nature. BIOS is firmware, a type of software that is stored on a ROM, read-only memory, chip. It contains the basic instructions needed for a computer to start up. Location. The BIOS chip is typically located on the motherboard as well. It's usually a flash memory chip that holds the BIOS firmware. Sometimes, older systems might have BIOS chips that are physically removable and replaceable, while modern systems often have soldered-on chips or BIOS stored in other forms of flash memory. In essence, while both CMOS and BIOS are integral parts of a computer's architecture, they serve distinct roles. CMOS provides volatile memory storage for system settings, while BIOS provides the fundamental software instructions for hardware initialization and booting. Number 2 is let's discuss the functions of CMOS and BIOS. Function. CMOS, Complementary Metal-Oxide-Semiconductor. Function. CMOS memory primarily stores system configuration settings required by the computer's hardware. These settings include information such as date, time, boot sequence, hardware settings like CPU clock speed, RAM timings, etc., and other basic system parameters. Usage. CMOS is essential during the boot process as it provides the BIOS with crucial information needed to initialize hardware correctly and boot the operating system. It retains its contents with the help of a small battery, ensuring that system settings are preserved even when the computer is powered off. BIOS, Basic Input-Output System. Function. BIOS is a firmware interface stored on a ROM, read-only memory, chip on the computer's motherboard. It provides the fundamental instructions and routines necessary for the computer to initialize its hardware components, perform self-tests, post, power-on self-test, and load the operating system. Usage. During the boot process, BIOS first performs post to check the hardware's integrity. It then locates and loads the bootloader from the designated boot device, such as the hard drive or a bootable USB drive. BIOS also facilitates the interaction between the operating system and the computer's hardware by providing low-level services through BIOS interrupts. In summary, while CMOS stores system configuration settings critical for hardware operation and booting, BIOS provides the foundational software interface needed to initialize hardware components, conduct system checks, and initiate the boot process. Together, CMOS and BIOS ensure that the computer system starts up smoothly and functions correctly. Number 3 is let's explore the concept of volatility as it pertains to CMOS and BIOS. Volatility. CMOS, Complementary Metal-Oxide-Semiconductor. Volatility. CMOS memory is volatile, meaning it requires continuous power to retain its stored information. Without power, the contents of CMOS memory are lost. Power source. To ensure that CMOS memory retains its settings when the computer is powered off, a small battery, often referred to as the CMOS battery, is used to provide power to the CMOS memory chip. This battery maintains the CMOS settings even when the main power source is disconnected. BIOS, Basic Input-Output System. Volatility. In contrast to CMOS memory, BIOS firmware is non-volatile. It retains its stored instructions and settings even when power is removed from the system. Storage medium. BIOS firmware is typically stored on a ROM, read-only memory, chip, which is inherently non-volatile. This means that the instructions stored in the BIOS chip remain intact regardless of whether the computer is powered on or off. In essence, the distinction in volatility between CMOS and BIOS lies in their storage characteristics. CMOS memory requires continuous power to preserve its contents, necessitating the use of a battery, while BIOS firmware remains unchanged and accessible regardless of power status. Number 4 is let's delve into the accessibility of CMOS and BIOS. Accessibility. CMOS, Complementary Metal-Oxide-Semiconductor. Access method. CMOS settings are typically accessed and modified through the BIOS setup utility during the computer's boot process. BIOS setup utility. During startup, users can usually access the BIOS setup utility by pressing a specific key, commonly Del, F2, F10, or Escape, as indicated on the screen. Within the BIOS setup utility, users can navigate through menus to view and modify various system configuration settings stored in the CMOS memory. Functionality. The BIOS setup utility allows users to configure hardware settings such as CPU parameters, memory settings, boot device priority, and system time and date. Changes made in the BIOS setup utility are stored in the CMOS memory. BIOS, Basic Input-Output System. Access method. BIOS settings are accessed during the computer's boot process by entering the BIOS setup utility. Initiation. To enter the BIOS setup utility, users typically need to press a specific key, e.g., Del, F2, F10, or Escape, as prompted on the screen during startup. This key press interrupts the normal boot process and allows access to the BIOS settings. Functionality. Within the BIOS setup utility, users can configure various low-level system settings, including boot device selection, hardware parameters, security options, and power management settings. Changes made in the BIOS setup utility are stored in the BIOS firmware. In summary, both CMOS and BIOS settings are accessed and modified through the BIOS setup utility during the computer's boot process. The BIOS setup utility provides a user-friendly interface for configuring system settings stored in either the CMOS memory for CMOS settings or the BIOS firmware for BIOS settings. Number 5 is let's discuss the upgradability aspects of CMOS and BIOS. Upgradability. CMOS, Complementary Metal-Oxide-Semiconductor. Nature of upgradability. CMOS memory itself is not directly upgradable in the same way as other components like RAM or storage. Configuration changes. While the CMOS memory itself cannot be physically upgraded, its settings can be modified, saved, and restored as needed. Users can update system configuration settings such as date, time, boot sequence, and hardware parameters through the BIOS setup utility. Battery replacement. Occasionally, the CMOS battery, which powers the CMOS memory to retain its settings when the computer is powered off, may need to be replaced due to depletion. This is not a direct upgrade to the CMOS memory, but rather a maintenance task to ensure its continued functionality. BIOS, Basic Input-Output System. Nature of upgradability. BIOS firmware can be upgraded or updated to a newer version provided by the motherboard manufacturer. Firmware updates. Manufacturers release BIOS updates to address issues, improve compatibility with new hardware, enhance system stability, and add new features. Flashing process. BIOS updates are typically obtained from the motherboard manufacturer's website and installed using specialized software tools provided by the manufacturer. This process, known as flashing the BIOS, replaces the existing firmware with the updated version. Caution. BIOS updates should be performed with caution, as an incomplete or incorrect update can potentially render the motherboard unusable. It's essential to carefully follow the manufacturer's instructions and ensure compatibility before proceeding with a BIOS update. In summary, while CMOS memory itself is not directly upgradable, its settings can be modified through the BIOS setup utility. On the other hand, BIOS firmware can be upgraded to newer versions provided by the motherboard manufacturer to improve functionality, compatibility, and performance. The applications of CMOS and BIOS are CMOS, Complementary Metal-Oxide-Semiconductor, and BIOS, Basic Input-Output System, are fundamental components in modern computing systems, each serving distinct but crucial roles. Here are their primary applications. Applications of CMOS. Digital integrated circuits. CMOS technology is widely used in the fabrication of digital integrated circuits, ICs, including microprocessors, memory chips, and other digital logic circuits. System-on-chip, SoC design. CMOS technology enables the integration of various components onto a single chip, leading to the development of complex SoCs used in smartphones, tablets, and other portable devices. Low-power applications. CMOS technology is preferred in battery-powered devices due to its low power consumption characteristics, making it suitable for applications such as mobile devices, IoT sensors, and wearables. Analog and mixed signal circuits. Although primarily digital, CMOS technology is also utilized in analog and mixed signal circuits, such as data converters, ADCs and DACs, voltage regulators, and audio amplifiers. Image sensors. CMOS image sensors are widely used in digital cameras, smartphones, medical imaging devices, and automotive cameras due to their low power consumption, high integration capability, and cost-effectiveness. Applications of BIOS. System booting. BIOS initializes and tests the hardware components of a computer system during the boot-up process. It performs a power-on self-test, POST, to check the integrity of essential hardware components like the processor, memory, storage devices, and peripherals. Firmware interface. BIOS provides a firmware interface between the operating system and the underlying hardware. It handles basic input-output operations, including accessing storage devices, managing system configuration settings, and interfacing with peripheral devices such as keyboards, mice, and displays. Configuration and setup. BIOS allows users to configure system settings such as date and time, boot device priority, CPU settings, memory timings, and other parameters through the BIOS setup utility. BIOS updates. BIOS firmware can be updated to fix bugs, add support for new hardware, improve system stability, or enhance performance. BIOS updates are typically provided by the motherboard manufacturer and installed using specialized tools provided by the vendor. Security features. Modern BIOS implementations may include security features such as Secure Boot, which ensures that only digitally signed operating system bootloaders and drivers are executed during the boot process, thereby protecting against malware attacks at the firmware level. In summary, CMOS technology is integral to the fabrication of digital integrated circuits and electronic devices, while BIOS plays a critical role in initializing and configuring computer systems during the boot process and providing a firmware interface between the operating system and hardware components.